Hi, students. Today's section in Metaforge mathematics system on the place of quartile, level 2, combinatorial mathematics module, the second session. The theme is about extreme value in the fundamental way. Advanced way, we will introduce it in mastery. Mastery tier, level 2. Okay. If you own this kind of qualification, this capability, the efficiency in this session will be good. Your good completion on grade 5 of K-12 system. And you have mastered Metaforge system level 1, logic pattern module, all sessions. A lot of theme in it, such as find the pattern of sequence, find the pattern of figures. Oh, okay. Do some Mensa intelligence test, algebra sequence, solve the puzzle extra, something like that. They are useful in this session. So if you don't understand the level 1, this module's content, your improvement will be limited. Okay. In this session, we only learn one thing, the standard pathway. We must, from theoretical extreme value, begin with this to build a solution, to construct a solution. At most case, you will not success because it is too perfect. It is theoretically perfect. But in real life, in real industry, in real business, in most case, it will not be happen. So, if unsuccessful, yeah, this half sentence is important. Is the theme of this session. Strictly back forward. For example, the extreme is least. You increase your theoretical number step by step. No jump, no skip. That is very important. That is meta thinking element we should learn in this session. Only this thing, only one thing here. Okay, let's go into the examples. Yeah, there are 10 decimal number organized by 3. Yeah, 10 of it. So the last one is 310 after the decimal point. Question. smallest number. Organize greater than 2. As example 1, it must be easy. Okay. Yeah, this 10 number bigger and bigger, but the range, the biggest gap is very small. From 3/10 to 1/3, this 10 number. In an open range, the largest one is smaller than 1/3. The smallest one equal to 3/10. Okay. Roughly calculate the smallest one, the biggest one, times 5. Obviously, it's not enough. Even 6 can't reach 2 because our largest one is smaller than 1/3, and 1/3 times 6 just equal to 2. The solution need bigger than 2. So 6 is work. Yeah, it can't work. Okay. Yeah, we must find the smallest one. So this number come out theoretically. Theoretically, we need, okay, 6 can't work. We need 7. In this sequence, the smallest one times 7 bigger than 2. Okay, equals to 2.1. Yeah. So 7 is this number, theoretically smallest number. And we build the solution. Any 7 number pick from this 10 number, yeah, equals to 7/3. So what we picked, the sum what we picked, seven numbers. Their sum must be between this number and this number. Okay, they are all bigger than 2. So we reach the theoretically smallest selection. In this case, theoretically number worked. We build a solution. We build a selection set to meet the requirement. So it's an easy example. Just because we needn't the later half sentence. Okay. Yeah. Example 2. 7 plants. 1, 2, 3, 4. 7. Each plant contains some toy. Okay. Glass ball. Okay. Total number, the sum is 80. And the plant 1 contains 18. This sentence is the key. the sum of any three consecutively number are the same, is the same. So, in level 1 logic pattern, we have learned it. This pattern means period pattern. Why? Any three consecutively number, consecutively. Any three, A, B, C. They own A, B, C glass balls, okay? So the sum is A plus B plus C. How about this plant? Because B and C are here, so here must be A. These three consecutively numbered are A, B, C. For the same reason, here is B. So we review the content in level 1, logic pattern module. Here is C. Is a period pattern. So in the cycle length is 3, because here is three sequence number. This can be anything, any large, okay, any number. For example, if we know any 5 consecutively numbered plate is the same, that is the period pattern. The cycle length is 5, A, B, C, D. Okay, the sixth one must be A, because the sum is the same. Any 5 consecutive number, their sum is the same. Okay, this structure means period. So our cycle length is 3. So here is 80. What is the maximum possible balls in the 6th? Here. So the construction of this problem is two period with a little tail, okay? Let me calculate. Yeah, the real sum, the real sum, the sum of one period is 80 minus 18, 2 period divided by 2 equals to 31. In one period, the classic ball happened 31 times. Okay. Another condition, restriction condition in the problem is, each plant owns sum. So here can be 0. In one period, the sum is 31. So these two number, the sum of these two number is 13. And the maximum here means minimum here. The minimum is 1. So here's 12. 12 is theoretically, the biggest one, the maximum. Okay, so the answer is 12. It's simple too. The example 1, 2, 3 will, in any our session, will not be very difficult. Even in math, Even in mastery tier, the first three example will not be very complicated. Example 3. Yeah, distinct digits. Multi-digit number without the same digit, okay? And the sum of the digits is solid, is fixed, is 23. Okay, what is the smallest one? Theoretically. What is the largest one? Theoretically. The first three example, the emphasize the theoretically. Okay. What the key point of this problem is about resource location. This is our all resources. It's fixed. How to make the output is the smallest. Allocate the largest as large as possible in source in the lowest efficiency place. Okay. Unit digit in the lowest efficiency. Okay. Put as as large as you can. Put it theoretically largest is 9. 9 can be used again. So in 10th digit, it should be 8. Yeah, in hundreds unit, 17, 6. So students, use your most important resource, the time, on the highest value section, highest value field. Okay. Yeah, then you can get the largest possible in theoretical, in theory. Okay, you can get that. How to construct it? Unit. Remember, it's not 1, it's 0. Okay, digit means 0 to 9. In unit place, the largest one should be 0, occupy no resource. In tens, 0 can't use twice. If 0 can use twice, I write a long chain 0. Okay, infinity. But the condition is distinct number. So here's one. In tens place, 2, 3, 4. Till now, what sum is it? 10. It's only 10. 5, 50. Okay. Only can place by 8. If here is 6, then 2 appeared twice. Okay? The number you write here must bigger than this. So the remainder, the remaining resource 8 must put in one place. So this is the smallest. This is the maximum. This is the biggest in theoretically way. Okay. But we have said in most cases, the theoretical way don't work. Let's go into the example 4. A strange country. A strange country, their currency is very special. 1, 2, 3, 5, odds 1, 3, 5, 7, and 9. What you should do is pick up the minimum number of bills. Can pick out any number from 1 to 100. Any number. Keywords the minimum. The minimum bills. The minimum means the largest unit, the largest dollar bill should appear in the main street. Okay. That means the gap between it from 1 to 8 must be organized in this number. 1 to 8 without any leap. 1 by 1. Okay. Let's do 1 to 8 1 by 1. Let us organize this number. Use this block. Okay. Use this basic element. Okay. We need 1. How about 2? Another 1. How about 3? Not another 1. Okay, because the number is too big. 3. 4, 5. Their sum is 5. But we can't reach the 6. How to do it? We need 5. 7 can't work. 7 can. If here is 7, 6 is not existing. Can't be organized out. Okay? So we must 7. 5. 5, 6, 7, 8. Oh, it's worked. 1 to 8, 1 by 1. Anything can be pay out. Okay? Then 9. How many 9? Yeah, it's good. The sum of the first 4 numbers is 10. So the biggest bill of 9 units need 10 bills. Okay. Exactly equals to 100. From 1 to 8, all can be organized. So from some times of 9, at this part, we will not lift any number. The solution is what? Check it. It is the minimum. It is the minimum number. Can this part be 3 bills? Is impossible. Okay. Check it again. 1, need 1 bill. 2 need 1 bill. If you only have 3 bills can be used, 1 to 8 can be combined out. Okay? So 3 is can't work. 3. 4 is the minimum. So what the minimum number? 4 small bill plus 10 bills of 9. This is example is about the construction your solution. Okay, the construction part, the designing part is here. Yeah, this is the principle. This is the main idea because you need the minimum number. So the biggest unit should be used broadly. Okay. Yeah. Thematically and the constructing were all mentioned. Okay. Question number 5. Example number 5. Yeah. That is the classical mathematical things about extreme number. 10 red ball, 6. Yellow, 10 yellow, 7. 10 green, 8. To combine some of them, target is 59. To find out the maximum possible red number, 6. It means 6. The maximum number of 6 to combine to 59. What is the theoretical largest? 10. 10 red. No, 10 red can't work. That is what I have said in most cases. Okay, that is classical daily life case. Okay, the theoretical number can't work. Out of range. Okay, then 9. Only 5 needed, but there are no unit about 5. These 2 units is too big. 7 and 8 can't work. Yeah. Retreat. Your goal is find the maximum. But our working direction is retreat. Retreat to a smaller one. 8. Yeah. Reverse the order. Step by step. 8. 8 rest. 11. 7, 8. Watch out this algebra expression. 11 can't happen. Okay, obviously. 7. Red. One red ball less. So the remaining number increase 6. So here is 17. Yeah. Non-green ball not work. 1 green ball not work. 2 green ball not work. In advanced number theory module, we will learn this algebra expression. The largest number, this expression can't can't organized, can't reach the sum. The largest one is what? We will learn that. You see, 17 can't work, can't be organized out. Okay, 16, okay, can. 15 can't. We will learn find the largest can't number in advanced number theory module in our level 2, but in the mastery here we will learn it. Okay, 6 can't work. Yeah, we walked back forward 4 steps. Any step we pause to try to construct our solution, but all unsuccessful, all failed. Okay? The 5th step. This number is here. Add 6. Worked. Here's 2. Here's 1. 23 is very near to 3 times 8. Okay? Okay. Letter 8 change to 7. It's work. Can work. From arithmetic, biggest number, maximum number. In every number we try to figure out our solution until we success. I have thought a lot of tragic things. Some students in the right step, but on construct a solution, they may make mistake. The solution can be built up, but they miss it. Then they work step by step, reversed direction. They find 5, 4, any other working is in web. Not only in web, but also direct you to wrong position. Okay, wrong direction. So the careless is very important. You are in the right place. Focus yourself. Can't miss the right solution. Okay. A lot of tragedy happens here. Doesn't matter. Next example. How about this? A long number trend from 1 to this year, 2026. The 2026 number right on the blackboard. Yeah. Each exactly once. Each time, a student raise 2 of them, but in the same parity. Why need the same parity? Because he must raise 2 and write down their average. The average must be integer. So, yeah. So the raised number must in both even or both odds. Okay? Write down their average. What is the max, maximum possible value. The thing is so big. It's so great. Don't be scared on it. The macro view is big, but we began from the micro view, micro step. We studied this operation. What Bob do in every step? From the number of number, from the number of number, he raised 2 and added 1. So, yeah, the number of the numbers minus 1. Oh, we understand. After 2025 actions, uh, the only number left on the blackboard. The blackboard, just only one number, okay? This number, we need its maximum. After this times of operation. This from number of the numbers perspective. From the sum of the numbers perspective, what Bob done? The average. He add the average. Okay, but he raised double of it. So the sum minus one copy of average. So from the micron perspective, what we should do, because this the sum is sensitive. Okay, from the knowledge here about algorithm, arithmetic sequence, we learned here. The sum of this sequence is they are a fixed number. So what we should do is keep this number, keep this erase, keep this minus, okay? Slow, low. Every step is the low. This action can happen. For example, the lowest average is here. Yeah, they are in this. They are both odds. Okay, erase them and add a 2. After this operation, the smallest average happened here, 2 and 2. The first time, the sum of this number set, the sum of them minus 2. In the second step, in the second operation, minus 2, 2. In the third operation, minus 3. Write down 3. What Bob write on the blackboard is just the sum loss. The sum loss. Okay, they are equal. Okay, write down 4 on blackboard. the sum minus 4. What you have found in pattern? Okay, in logic pattern, you will find according this pattern, the last two number always the largest number and their label, their label party number. Okay, the last number is even. Yeah, when the blackboard left two number, that these two number. So minus 1025 leaves 2025. So the maximum possible value of this number is here. You can ask yourself, what's the minimum possible value of this number? You can do it after this session. Ask yourself. When you meet the request of maximum, you can ask yourself about minimum. Do something like that. This direction, reverse direction. Now, let your thinking still working. Okay, just like training your body's core strength. Okay, let your mind thinking. Yeah, this is from theoretically number to smallest number. This is in this problem, the whole process appear. Let's read the problem. 10 bags of gold coin from 1 to 10. Award to 3 men, A, B, C. Mystery A, B, C. The number A owned have the property of, divide their coin without opening the bag. Divide the coin equals to type. That means A own, two equal type. A on this number. This expression expressed by algebra expression. Okay, this is A. For the same reason, one pile twice another. One pile twice 3y. That is B. C. One pile 3 times as another 4. So A minister plus B minister plus C minister. The sum is certainty 45. We have learned it in algorithm sequence session. Okay? Yeah. Minimum number. The theoretically minimum number here is 2. But it just like we have said, in the most case, the theoretically number don't work. 2 can't work because then has no double 2 in the 10 bags. 2 not work. 4. 1 to 10. Anybody, A, B, C, anybody, be avoid at least 2 bags. Otherwise, they can divide their award into 2 pies. Okay, the bags must at least 2. So 2 number add to the 4, 1 and 3. But can divide them equal piles? No, no. 1 is not equal to 3. 6. 6. And can be separated in 3 and 3. 3 and 3. There's only one way. 1, 2, 3. Okay. 1, 2, 3. Occupied by minister A. So here, that remind the problem about this. Minus 6 equals. Okay. Here is times of 3. Here is times of 3. Here is not. The only way is Z, the C. Yeah, the Z is times of 3. It can be 3. 3 is not work. Yeah, because one pair of minus C need a golden coin 3. 3 is be occupied. So here 3 is not work. Or 6. If here is 6, 24. 24. Here's 5. Can it work? Minus B on 50. Minister C occupied be award this number. 5th. 5 must be occupied by B. And the other is 10. Okay, worked. So B owns this number. One pile organized by 4 and 6 is twice to 5. Yeah, this worked too. Oh, not work. Not work. Oh, okay. Because the 6 is occupied by minus B. So the minus C is 6. 6 is 1/4 of the whole occupied. Be occupied. Okay. It's not work. It's a very tough solution build up process. 6 not work. 8. Just because. How about here is 9? 9 is not work too. Okay. The first thing you should know is the Z. The minus 6 basic number must be the times of 3. Okay. So Z, we only number we can try into the Z is 3, 6 times. There are no work. Okay. How about 8? Here is 8. So x equals to 4. 4. 4 must be occupied by A. And 1, 3. That means A owns 1, 3, 4. Then left the remaining problem is to this number. Okay, this number Y. Y equals to 7. Here is 21. Z equals to 4. And I leaped the process of trying. Okay. And here is 7. Here is 3. Okay. Yeah. The basic pair. The basic pair of B is 3 can't work. Because 3 is occupied by A. This can't work. This can't work too. Because the basis of the Z of this pi, C small pi, okay, the last pi, the basic number is 4. 4 occupied 2. 8 is not work. That is the difficulty on the extreme, pursue extreme number. It's very similar to our real life. Iteration 1, 2, 3, 4, 5 times. Worked again and again and again. The other difficulty happened is strictly according to the order. In real life, the order is not very obviously, but in mathematics, see, the order is clear. Okay? 10. I tell you 10 is work. The lecture is 50. 50 minutes. So I jumped here. You find out by yourself. If A occupies 10, means 1, 5 owned by him. Now, 5, 1, 4, or 5, 2, 3 can be reward to the A. Then, students, by yourself, construct the remaining part. Okay, the last one, the later one. Yeah, natural number from 1, write in order. 1, 2, 3, 4. Okay. This long chain, number chain. Okay, number chain. Okay, write down here. Insert a addition signal here. Keep the sum, keep the result small. This mathematics thing is about place value. Okay. Small means the number of digits keep small. Yeah, we know the power of adding digits. For example, here's 2. You add in the digits longer one place. Yeah, the new number is almost 10 times of old number. This is called increased order of magnitude. Enlarged the magnitude. One magnitude equals 10 times. Okay, so our main task is keep. Yeah, the number of digits smallest. So the first subtask is to find out how many digits here. Let's calculate it. 1 digit number from 1 to 9. 9. The number of 9-digit number is 9. 2-digit number from 10 to 99. Yeah. in the session here, level 1 logic pattern. In the session of algorithm sequence, we know the way to find out the items of arithmetic sequence. This item number is 90. The last item minus the first item plus 1. Okay? The common difference is 1. So here is 90. The digits here is 9. The digits here is 180. So this is 189 digits here. How to keep the sum is small, the most nearly to parity this 180. But it is not a even, it's a odd. So one part is 94, one part is 95 digits number. Then from beginning of the 1, 2, 3, add here. This number is 95 or 94. In the most case, it should be 95. Because this number, the beginning, the highest digit beginning here, in most cases is bigger than 1. Okay, so let's construct the solution first from the previous half is 25 digits and the back is 24. Use the knowledge of period pattern again. Okay? Yeah. After 9, 2 digits a period to push the real number back. So here is 95 minus 9. Let me see how much digits happen here. Okay, here the cycle number is 2. That means the remainder is 0. That means 10, 11, we write down till the number 43, 2-digit number. What is it? From the knowledge of algorithm sequence, we know it's this number. So without the background of our level 1 knowledge, learn this section, you will feel difficult. Okay, that is 52. Here begin with the 5th. Well, with the 5. Okay. So the large number in the highest digits should be 94 digits, and from 1, highest value place is 1. For keep the result, the sum is smallest. Keep the sum is minimum. Little less highest digit can occupy longer. Okay, longer chain. Last 4 digits. Here is 5152. Here exactly. Yeah, this four number. These 4 digits. Okay. Yeah. So the last 4 digits is here. It's a comprehensive, big problem. The first, you must exactly, precisely calculate out how long is it. Then you know how to separate them to keep the sum small. Yeah, nearly average to separate them. The third, the small highest number config the longer, yeah, the longer digits. If the result is even, for example, yeah, that's simple. 100, 105, 105 digits. Okay, but in odds, the smaller highest digits config the long chain. Okay, it's comprehensive. It's a little complicated. It's interesting. A digit, 2 digit number divided by, yeah, this part is not important. The question is about the remainder. The remainder wants the biggest. That's the ideal mathematical thing for this sentence. Okay? From the theoretical starting point. Because the remainder is less than divider. This is divider. You want the remainder keep big. Yeah. You should let the divider big first. The biggest one is 9, 9. Theoretically, the remainder can reach the 17. Let me try it. If here is 99, 99 divided by 18, the remainder, not reach the 17. It's just 9. 9 is not very big. Okay? So theoretically, number is not very good. Move back forward. 70. The divider is 70. The biggest remainder can reach 60. 70, 60. Okay. It may be 98 or 89. Yeah. 5 times of 17 is 85. 85. So this remainder is 4. 85. This remainder is 13. Okay. 70 times 5 equals to 85. Yeah. So 9. Yeah. 60. Not reached 16, but it's quite big. Is that the answer? No, because there are gap. 16 to 13, there's gap of 3. Let me try another. Okay. Divider is 16. If divider is 16, we can reach the remainder is 15. That is the biggest. Because we strictly walk backward one step by step, step by step. Okay, there are two scenarios. 79. Yeah, yeah, 79. One difference from 18. 80, one difference from, so the remainder is 60. Find it. Bigger than 30. Okay, here it's only one. Here is 8. Okay, 88 divided by 80. 50 jumped out. So the sum of the digits is not need to try because other reminders are less than 50 and the 50 jumped out. Yeah, work back forward one by one. Sometimes in the later session, you can implement this logic in algorithm. Control your computer, control your AI. Let them implement your ideas. Okay, what you should do is provide ideas. Okay, a lot of tools can help you. The last one, a long session here, over 1 hour. Let me see, 1 hour and 7 minutes. Okay, 7 distinct long-lective, yeah, including 0 to 100. The sum is 100. 3 sub-question. Yeah, 2 layer of logic. Maximum possible number of the largest one is simple. 1, 2, 3, 4, 5, 6, 7. Keep this biggest. That means here is the smallest. Okay? Just keep this part is the largest. This part is the smallest. So the first subtask is very easy. Here is 15. So here is 85. Okay, distinction. Yeah, the later two subtasks in the same logic. Yeah, the two words is opposite. The maximum possible value of the smallest one is difficult. This number 1, 2, 3, 4, 5, 6, 7. This smallest, low. Okay, that means what? We should keep this number very close. The first 6 number occupy as much as you can resource. See 100 as the total resource, but not bigger than this one. Okay, this one can smaller than this one. Yeah. So here can be small. Okay, that means all 7 number gather. Their distance is very close. How to find it? Average number. 100 resource allocate to 7 person. Every person about gets 14 resource. Okay. in arithmetic sequence knowledge, okay, the middle number almost is 14. So here is 11, 14, 17. Is now we allocate the resource of 100 minus 2, 98. How to do it? How the other two resource replace it, and keep the smallest, the largest, keep down, uh, keep it minimum. How to allocate the other two? Here minus 1, here minus 1. Add 1, here add 1. Yeah. No number is same. All number is distinct. 11 to 15, then 17, 18. Minimum number, keep the biggest, is 11. From 12 to is bigger than 100. Is the sum of the sequence is 105. Use the knowledge we have taught here. Okay, I've taught in level 1. You need it. A long session. Let me give you a summary. Only one sentence. A lot of mathematics scenario we used. We used the standard approach in many mathematics scenario to apply the fundamental concept. What is fundamental concept? Fundamental way. This sentence. Beginning from the theoretical extreme value to construct a solution to meet the problem requirement. In the most case, you will not success. Strictly step by step. Move backward. In each step, you must rebuild the whole solution. Use the mathematical knowledge about arithmetic sequence. We use a lot of time. Period issue, okay? Resource allocation principle. Single operation. Single. From the micron perspective, single operation. In this single operation, the number of the numbers minus 1. The sum of the numbers minus the average. Okay? Place value. Understand our number system. Reminder. So many scenarios to prove one sentence, one thinking model, one skill set. Students, you should complete the necessary exercise to truly master this session's spirit. This session's key capability, or called mental capability. So you must do your self exercise, just like build your body's core strength. The homework for this session is attached below this video. The answer and some hints for the homework are listed in the homework file itself. Okay? Allow you to self-check-in, reflection, self-improvement. Even ask me for more exercise. You can contact me for more exercise. Okay. See you next, or see you mastery sessions. See you.